In this video, we're going to write code to search for a value in a linked list. So this is our start pointer. It's pointing to the first node of our linked list. And remember, because we have to search a value that is there in our linked list, we'll have to go through the different nodes in the linked list. So we'll start here, and we'll check this value, then we'll go to the next node, we'll check this value, then we'll go to the next node, check this value, and and see if we found our value or not. So basically we're going to start from the first node and we'll keep traveling, right? For example, if we are looking for value 53, we'll start from this node and we'll keep traveling, and once we found 53 we'll stop, right? We don't need to go further than this, right? That's one of the scenarios that we have. But what if we are looking for a value such as 76? If you're looking for a value 76, we come to this node, we'll not find it here. We come to this node, we'll not find it here because this is 53. Then we come to this node and we'll not find it here because it is 85. So the key concept here is there are two possibilities. One, as you are traveling down the linked list nodes, you might find your value 53 you were looking for, you found it and you stop. And the other scenario is that you keep going through all of these nodes and your search fails because you were looking for 76 and you couldn't find it. Now the other very important concept that we have in this is that to go through all of these nodes, we are going to need a temporary pointer. We'll need a temporary pointer, and that temporary pointer must initially be positioned here towards the first node, right? And then we'll make this temporary pointer travel down to the second node, searching for our value. If we haven't found it, then it moves to the third node, and this is where we search for our value, and if we haven't found it, we stop, right? So the key concept here is that when we want to travel through the different nodes of our linked list, we are going to need a temporary pointer for that. That's a very, very important concept. So we are, and one more thing I should explain, as for reference in this video, if our temporary pointer is pointing here, and let's just name our temporary pointer, we are going to call it TNP. If our temporary pointer TNP is pointing to this node, then we'll consider this as a current node. And when temporary pointer moves from this node to this node, right, TNP points here, then this will become a current node. Okay, so the node towards which temporary pointer is going to be pointing, we are going to call it as our current node during discussion. Okay, so let's start writing our code, and the first thing I'm going to do is I'm going to declare a procedure which is going to be implemented to search for the value in our linked list. So I'm going to declare my procedure first. So we have declared a procedure, it's called search linked list, and there is one parameter being passed to the procedure, and this is basically the value that we're going to be searching for. Now inside of this procedure, the most important thing that we need to understand is that we need to use a temporary pointer because we have to go through the different nodes, right? So to travel through the different nodes, we need a temporary pointer, so let's declare that. So now that we've declared a temporary pointer TNP, we want to position this temporary pointer to point towards the first node. We want to position it here. This is where this temporary pointer should be pointing, right? Because that's the starting point. This is where we're going to begin our search. And so in our code, what we've done is we've set TNP equals to start pointer, which means now we have two pointers pointing at the same node, right? There's the start pointer and then there is TNP. And remember I said the node towards which TNP is pointing, we are going to call that node as our current node. Okay, so the first thing we need to do is that we need to write code to move TNP from node to node in our linked list whilst we are searching for our value. Now to move TNP from node to node, we are going to write a loop. We're going to write a while loop, and within this while loop we are going to write code to update the value of TNP so that it can move from one node to another node. But before we write the while loop, it is very important to understand that there are two possibilities. One possibility is when the search is successful, such as we are looking for the value 53, right? Such as we are looking for the value 53 and we found it in our linked list. At this point, because we found the value, we should stop our search, meaning the loop should stop and we don't need to move TNP any further because we have found the value 53 in our linked list. And the second possibility is when our search fails, such as when we are looking for a value 76, right? And 76 is not in our linked list. In that case, TNP will keep moving from node to node. TNP will come here, then it will come here. So we'll keep going from node to node until we reach the final node. And at this point, TNP will finally become equal to null because we can see that this node is not connected to any other node. So these are the two possibilities, and in this case, if you're looking for 76, because our search fails, we start from the first node, we keep going down until we reach the final node, and finally TNP becomes null. When TNP becomes null, we should stop our search, and we don't need to move any further, right? So we don't need to move TNP any further, which means we should stop our loop when TNP becomes equals to null. And what I've done now is I have written my while loop, and I'm saying that this while loop will keep running as long as TNP is not equal to null and as long as found is equal to false, which means what? If we've not found our value, right, then found stays false, and that's if we've not found our value, then we are going to keep searching in our linked list through further nodes, right? So this loop will stop once TNP reaches null, right? As long as it is not null, TNP will keep running. Remember, when we write a while loop, we write it for the running condition. So we are saying this loop should run as long as TNP is not equal to null. But once TNP becomes null, this loop is going to stop. And this loop is going to run whilst the value of found is equal to false. But once the value of found becomes true, then this loop stops. So I'm using this Boolean variable found. Therefore, I have declared it here. And once I've declared it, I've set its initial value to false. But we know inside the loop we are now going to write code which will set the value of found to true if we found our value. Okay, so we've added code which is going to set a value of found equals to 2. Just remember one thing, that all of these nodes are lying in an array, and we are going to call our array list. It makes sense because we're dealing with a linked list, so we should have a meaningful name for our array. Because all the nodes are lying in our array, that's why we've given the name of our array here. In our array list, go to the node that TNP is pointing at. So this is our current node. Go to the current node and look for the data value in the current node. If the data value in the current node is equal to the value that we are searching for, remember this value was passed as a parameter, data item. If the data value in our current node is equal to the data value that we are searching for, then set found is equal to true. But if that is not the case, if we've not found the data value in our current node, we need to move TNP to the next node. So we are now going to write code that is going to update the value of TNP in case we have not found our data value in the current node. And that is exactly what we've done here. In the else statement, so if this condition is not true, then we come to the else part, meaning the current node did not have the data value inside of it that we were searching for. So then we come to the else part, and this is where we want to update the value of TNP, right? So we want to move TNP to the next node. For that, we write our statement. We want to change the value of TNP, and we want to go to the current node. And remember, the current node is lying in our array called list, and this is the pointer for the current node, TNP. So we use list TNP to go to the current node, and in the current node, the field pointer, its value needs to be given to TNP, right? So that's how we are updating the value of TNP. and we have moved to the next node. So this time from this node we come to this node, right? Because we've updated the value of TNP, and now this node becomes our current node. So when the loop runs the next time, all the operation is going to, all of this code is going to act on the current node, right? Because we are trying to see if the current node data value is equal to the value that we are searching for, and if that's not the case, go to the else statement, right? And you need to update TNP using the current node, right? The array list and the the pointer value of TNP, right? So this gives us the current node, and in the current node use the pointer value, this is the pointer value, to update TNP, and in this case TNP is once again going to move to the next node, right? So I hope you've understood how this code is working. And so one way this code is going to stop is if found becomes equals to true. The other way that this code is going to stop is when TNP eventually becomes null. So once this loop has stopped, right, once this loop has stopped, we can now output our messages, right? If found equals true, then we are going to output the message that the search has been successful, and if found equals false, that means we'll go to the else clause and we'll output the message that the search failed. Okay, so far we've written a procedure to search for a value in a linked list using a while loop, but we can also search for a value in a linked list using recursion. And for that, I'm going to declare a procedure, and I've declared this procedure, and I am calling this procedure search linked list recursively. Okay, and within this procedure I need to pass two parameters, and the two parameters that I'm passing here are the temp pointer and the data item. And remember, the data item is the value that we are searching for, and the temp pointer here is the pointer to a node. And the concept is, first our temp pointer, and temp pointer is just behaving like TNP, and this temp pointer is going to be pointing to the current node, right? So first we place our temp pointer somewhere here, right? And once we are done checking here, once we are done checking this node, if we've not found our value, we once again call the same procedure linked list, and we pass this pointer here as a temp pointer, right? So each time we call this procedure search linked list, remember, a recursive procedure is a procedure that is defined in terms of itself. So within this procedure we are going to be placing a call to this same procedure, but whenever we place the same call, whenever we place the call to the same procedure, we'll always pass the next node, right? So first temp pointer was here, next we are going to update temp pointer, and the updated value would make temp pointer point towards this node, and then we'll call this procedure again. And then we're going to check this node. If we've not found our value, we are going to update our temp pointer, right? And we are going to update it to this place, right? And then once again we are going to call our search linked list function, right? So this is what recursion is, and we're going to implement it using code. So the concept here is that we keep placing these calls recursively. We go from node to node, and each time we call the same function, same procedure, right, until we found our value. So if we were looking for 53, we first come to this node, we check this node, this is our current node, we check if we found the value. If we've not found the value, we place a recursive call using, by first updating our temp pointer, making it point to this node, and then we place a recursive call. Once our temp pointer comes here, then we check once again if we found the value. If we found the value, that is where we stop. We don't need to place another recursive call, right? So that's one of the ways our recursive calls are going to stop. And the second scenario is that this is where our temp pointer is, right, for example, and this is our current node, and we're looking for a value 76. So we keep checking each node, we keep updating temp pointer, we place a recursive call using the next node, we don't find our value here, so we update our temp pointer, we move it to the next node, we place the recursive call once again, and we don't find our value here, so we update our temp pointer and we try and move to the next node, but this node, its pointer is set to null, which means it's not connected to any other node, so temp pointer is eventually going to become null, at which point we should stop our search, which means we should stop placing further recursive calls. We don't have any nodes left, so we can't place any more recursive calls, right? So that's another reason where that's another way where our recursive calls are going to stop, when the temp pointer is going to become equal to null. And remember, we are passing temp pointer as a parameter. We are passing temp pointer as a parameter. So each time the recursive call is placed, the node at which we are interested in, the current node, its temp pointer is also passed as a parameter, right? So this function, it already knows the value that has to be searched because that's been passed as the parameter, and it also has the temp pointer which will tell what current node it is that we want to examine. So let's take a look at the code that we are going to write inside this procedure. Okay, so one thing is very obvious, that if TNP is equal to null, right? If TNP is equal to null, that means we are here, right, in the else clause. If TNP is not equal to null, we'll have to place a recursive call. But if TNP is equal to null, that means we come to the else clause, and that's where we can output a message that the search failed. We've gone through each node, but we've not found our value, so the search has failed. So this much is pretty simple. If TNP becomes null, we know that the search has failed. So that's the first thing that we've implemented in our code. So now let's concern ourselves with the situation when TNP is not equal to null. When TNP is not equal to null, there are two things that we should do. First, we should check that the current node that we've just received in the procedure, does that current node have the value that we are looking for? So we're going to examine the current node and see if this current node has the value that we are looking for. And if in a current node we found that value, if we found that value, if the current node, right, in our array list, the node that temp pointer is pointing at, that's our current node, if the data value inside of our current node is equal to the value that we were searching for, then we can output the message that the search has been successful. In this scenario, we do not need to place a recursive call, right, because we've already found our value, so we don't need to search any other node, therefore we are not going to place any other recursive call. But what if we've not found our value? What if the current node does not have the value that we are looking for? Then we come to the else clause, right? And in the else clause, we're going to have to pass we're going to have to place a recursive call, because now we need to move our pointer to the next node and examine the next node to see if the next node has the value inside of it. So now we need to place a recursive call, but we must first update our pointer, our temp pointer, to point to the next node. And remember, we always use the current node to get the value of to find where the next node is, right? So for the current node, its pointer value is going to be used to update our temp pointer. So let's write code for that, and that is exactly what we've done here. And that is exactly what we've done here. What we've done is we've updated our temp pointer, right? We've updated our temp pointer, and I've updated it using the current node. Remember, in our array list, the node which temp pointer is pointing at, that's our current node. Its pointer value, the current node's pointer value, is now being assigned to temp pointer. So temp pointer has moved to the next node, right? And then we place our call, search linked list recursively, right? That's the name of our procedure, right? So we're calling the procedure itself. We're calling the same procedure, and we are passing the new value of the temp pointer and the data item value, right, that we are searching for. So what's going to happen now is that, each time the temp pointer moves to the new node, because a recursive call has been placed, first we are going to check if the data value has been found, and if it has not been found, we come to the else clause, we update the temp pointer, and we once again place a call to the recursive function. So that's how our temp pointer keeps moving with the help of recursive calls through different nodes. And if the value is found, then if this is where the temp pointer is at, let's say we were searching for 85 and this is where the temp pointer is at, right? So when we come to this line here, then list temp pointer dot data will that value is 85, and the data item that we are searching for is also 85. Then in that case we'll output search equals successful, right? And you can see here that no recursive call is being placed here. So automatically, because we are not placing a recursive call, our code is going to stop, right? It won't run anymore, right? So if a value is found, this is the part of code that gets executed. If a value is not found, then this is the part of code that gets executed, and this is where we place a recursive call. And each time a recursive call is placed, the first thing we check is whether TNP is not equal to null. If TNP has already reached the null pointer, it has already become null, then we come to this part of the code and we output that the search has failed. And obviously you can see here that no recursive call is being placed from this part of the code. So I hope you understand how recursion works when we are searching for a linked list.